Soundcool Online is a new implementation of Soundcool using web audio. I'm going to describe Soundcool, our new implementation called Soundcool Online, a new collaborative performance facility, and some future work. The Soundcool project started in 2013 as a system for music education using digital and electronic sound. Soundcool is interesting because it is modular, allowing for creative construction of instruments, sound processing, and interactive audio-video performances. Soundcool is collaborative, allowing multiple performers to control it through tablet and smartphones connected over Wi-Fi. And finally, Soundcool is educational. Modules come ready-made with interfaces, communication, and lots of functionality built in. Soundcool is easy to use, even by young students, and the distributed control works well in a classroom setting. Original Soundcool is implemented in Max MSP and runs on Windows and Mac OS, and it is completely free. We think Soundcool is pretty unique, but of course there is related work even in the web audio area, so please see our paper for some references. We were originally attracted to web audio by requests to offer Soundcool on Linux because many school systems are using Linux. Once we thought about it, we realized running Soundcool in a browser would enable easier installation and updates. Also, a web-based Soundcool can allow sharing of online projects and sounds, facilitating collaboration. Finally, there are new possibilities for performing over the network, which we will demonstrate. I'd like to give a quick demonstration of Soundcool Online. After logging in, you can create a new project, which gives you a blank slate. Here you can create and arrange modules, you can connect them together, and you can try them out. They're running all the time. There are separate pages where you can upload sound clips for use in player modules. Let's look at how shared control works. The idea is that audio is created locally for each user. Parameter changes are sent to every performer so that, except for slight timing differences, every performer hears the same sound. Each user runs the Soundcool app, which looks like this, on their mobile device and sends OSC messages to the server. The server keeps track of who is in the performance and sends messages via WebSockets to each performer. So if user 1 moves a control, it looks like this. Any other user can operate controls at the same time, like this. Parameter changes are strictly ordered by the server and by WebSockets, so each performer gets the same parameter updates in the same order. Latency is a big concern, so we measured latency in our system. A big factor is touchscreen latency, which is about 90 milliseconds. We measured parameter change to audio output latency and web audio to be about 45 to 52 milliseconds. Network latency is largely due to the speed of light in fiber, so it varies from 33 milliseconds round trip from Pittsburgh to the nearest AWS cloud in the US, up to 260 milliseconds round trip from the US to China. Within a classroom using a local server, the number could be 5 or 6 milliseconds. So the results show that, except for international collaborations, latency is actually dominated by touchscreen technology. We expect that to improve, and we hope the second factor, web audio itself, improves too, since it's an order of magnitude higher than many audio applications. Soundcool Online is not yet production quality software, but we're working on it. We also want to add more audio modules and begin implementing video processing modules. We're re-implementing the Soundcool app to be just another web page so you can visit with your phone or tablet. In conclusion, Soundcool Online has the potential to reach a large young audience of future electronic musicians. Web audio is an ideal technology to provide a simple-to-use and widely available system. If you have another 90 seconds, we'll end with a video of an international network performance that demonstrates Soundcool Online.
you.